So now we are going to start with our program with our next 3 presentations about healthier. Afterwards, after the presentations, we will have a short Q&A here on stage, and afterwards you have the possibility to ask your questions over there at the booth directly in one-on-one conversations. So now we will have a deep dive into healthier. And I have a question for you. Who of you has a smartwatch today? Smartwatch? Okay. Thank you. And who of you has an earable? Earable is a small device in your ear, and it measures, like the pressure and health data. Who of you has an earable in the ear? Okay, actually I expected that. So Professor Dr. Michael Beigl, he is going to talk about earables, wearables in general, and an earable, the small device. So it will help us, it will open up new possibilities in the field of health monitoring. On the other hand side, of course, in Germany, it's a huge topic. We have to talk about the data, about the storage of the data, about the processing and the interpretation of the data. And he is going to talk about wearables, health technology on the body. Very warm welcome, Professor Dr. Michael Beigl.
Yeah, thanks a lot for the introduction. Sorry for making you nervous at the very beginning, but probably that's a good start. Actually, I don't wear a smartwatch. Anybody knows why I don't wear a smartwatch? No, I don't care. I have a smartphone, so I will be tracked anyway. No, the reason is actually this place is not a good wearable place. Yeah, so many people, I also don't wear a watch, are uncomfortable wearing these devices. This is why a lot of young people now switch to anything on the ear, because this is a convenient place actually. Yeah, so this is wearability. I will talk not a lot about wearability, so no deep dive, unfortunately, because of the 15 minutes that I have. But I will talk a little bit about wearable health technology in general, and also a little bit of our genesis. The presenters here. Good to know. But let's first start at something which is related, of course, to what we are doing, but shows a broader perspective on what we are doing. And this is our initiative and our center now on health technologies. Our center on health technologies is pretty new. It has been grown up by a grassroots movement, if you want to say like that, across all faculties. We had a workshop and several talks with a lot of people that bring in their idea, because we felt, a few people here felt that there is so many ongoing in health technologies inside the KIT that it has to be brought together, to make something bigger and to start a movement here inside the KIT to make that present and also to bring the technology forward. And this is what we did, like almost 2 years ago. And then we continued on this process, and now we are a center inside the KIT, which we divided in some subtopics. This is the precision medicine, individualized patient care, and digital health. And of course, I will not be able to talk about all of them, so I have only a part of the spectrum that I will present here. But you see topics like wearables, but also the digitalization is here, and these are the 2 topics that I will touch in my talk. And this is important that we from the self-motivation of all the people, form something where we move together to one direction. And this is what we made. And then we asked ourselves, what is something unique and what everybody needs in the research on health technologies. And so technology-wise, but also from the principle. And we found that nowadays in our research, the data and basically getting the data, in health technology, getting the data means always involving of a human. Yeah, because you need data, health data from a human, but also the storing and the processing of the data is very individual, but overlapping. And so by just starting that, bringing that in a consistent format, as you see it here, and having a common way to handle it, also common underlying technology to support it. I will later on show one of the tools that we are using, will be very beneficial for all of us together. Yeah, so we can, so we work together on this common technology, also common methods, like methods in that we get data in living labs from people, but also on supporting technology that that everybody adds some piece to it, and we commonly use it, and also common data, so we can all use this data for our research. And the outcome is this then, that we are able to do something which is novel. And we look into predictive health technologies, where we try to simulate health-related phenomena. Yeah, basically simulate a human. That would be the ultimate goal. Simulate an individual human, so that we can tell you how you will develop health-wise, and what you can do, and how does this influence your health. Yeah, including, of course, anything which goes into medication. Yeah. So to make it very concrete, yeah, we tell you that if you continue like that, you will have a stroke in 1 year ahead. Yeah, and actually, there's basic technology. Also, part of that is shown over there. That is actually going towards that direction already. Yeah. Okay, talking about. I don't want to talk about in the very broad thing. I will talk about two specific technologies that we and my group brings into that health technologies. And the one is the open Wearable platform, and the other is the data platform, data and AI computation platform, which is HML. Starting with open Wearable, which is also on display over there. We asked ourselves, what would be a good platform, wearable platform, where we can measure continuously health parameters? And also, so health is very broad, including your activities, etc., because this relates also a lot to your health. Yeah, there was like 3 weeks, I guess, a study. I think it was in Nature. Yeah, walking speed relates to intelligence. Yeah, that might be a coincidence, yeah, and I believe that is the case, yeah, but they could at least show it, yeah. Anyway, we want to have a platform that where we are able to extend, also to add sensors. You see it, we added a special earpiece. Of course, you can just use it for hear your music, of course, yeah. Otherwise, people won't use it. But you can also measure, for example, the inner ear pressure. The inner ear pressure is very interesting, because the inner ear pressure, if you have 2 inner ear pressures on both ears, indicates if you are going to have a stroke. Yeah, and things like that, novel types of sensors, novel types of algorithms that then use the data from these sensors, also from off-the-shelf sensors, also optical sensors, where we work together. So in the sensor technology nowadays more with Bosch, but probably Trumpf is also working with Bosch together now in sensors. So probably opportunity here. We try to we develop this platform to research on new sensors, new algorithms, but also to make health-related studies together, of course, with clinics. You can also use it also in the psychological domain. You know, almost half of the patients of today, people which are sick, have psychological problems and not physiological problems. So it's also important in this domain. There are also a lot of diseases which can be monitored and which treatment can be, of course, supported by such technology. And for human-computer interaction, it can also be used. You can have to do hands-free input in the earpiece. Yeah, for example, not only with that, this we already have, but that is not hands-free. Some of you, about 40% of you, can use your tensor tympani. That's the smallest muscle that you have. It's inside the ear, and everybody has it, of course, but it's mostly used to regulate the pressure in the ear, but probably you can also use it explicitly, and if you can use it, you hear such a rumbling noise inside the ear, and this we can measure. Then you have an input, for example, for hands-free use in certain situations that is very beneficial. Industrial situations, in surgeries, this is very beneficial. Such devices, as I said, can be useful and can be a replacement or an addition to traditional ways that we use health technologies. And that is also important because as of today, the costs and also the energy consumption that we have in the health domain is rising pretty fast. That is also because of the aging society, and we need to find ways to make that cheaper. And for example, if you have a stroke, you go in, or you think you have a stroke, you go into a hospital, and then you get an MRT, yes, that you see here. The MRT is pretty expensive, also in terms of money, but also in terms of energy, as you see, 20 kilowatt hours you need for an examination. About 40% of the patients, or the in-speed patients that may have a stroke, do not have a stroke, yeah, not even the slightest one. And a part of that can be easily found if you had other means. Yeah? And one possibility, as I said, is measuring the in-ear pressure on both ears high precisely, and then you have a much cheaper way to supervise that, and also a much faster way. That is also very important because you can do that, of course, directly, and you don't have to wait until your slot in the MRT. So we make basic technologies, and that's not only for us, but here in our example, of course, for the open Wearables. It is important that this technology can have many uses, also uses that we can then apply, for example, in the industry. And this is what you see here. So when we design our research systems, then we look what are the phenomena that we can detect, and then conclude on what type of sensors are needed, what types are already on the market, and which types do we need to research on. That includes, of course, the algorithms that are needed to get the information at the end. And with that, you can do a lot, yeah? And these are just a few examples. One is you can use it for rescue. Cardiopulmonary rescue requires you to do a certain pressure on the breast, yeah, to bring back the person to life. But the problem is always, yeah, how much? How deep should you press? Yeah. So the rhythm is normally not that much of a problem, but the deepness of press and the release, that is a problem for anybody, and you have to train hard to do that correct. We can do that on the ear, yeah, because you have the device has accelerometers and gyroscopes, and that is enough, yeah, to tell you how deep you are really pressing, and we have shown that it is in the same range as a professional rescuer would do it. You can do it for respiration monitoring for various types. So in the sleep, for sleep apnea, which is a problem, especially also in the aging society, but also, of course, for anything which is health-related, yeah, etc. And you can also do, of course, then cough detection. Yeah, so we can tell, depending on the cough, also a little bit about what type of cough it is, and probably what reason it is. And this was, of course, in the COVID times, interesting study here. You can do human-computer interaction. With EOG interaction, you have both physiological parameters, because your eyes are a nice sensor for your physiological condition, also a good indication for certain diseases that you may have, or other health problems that you may have, but can also be used as an alternate human-computer interaction where you only use your eyes. And of course, you need AI, and I will show the HML platform and a startup that comes out from my lab. Validator will later on go into validation of the models that we need, yeah, because these models, of course, yeah, because we are in the health domain, need to be extremely stable. So one important part of the show is, of course, the tools, yeah, and here the data tools. Everybody needs it, yeah, and we need tools that are easy to use, yeah, for everybody. You cannot start by researching on your new algorithm in every application. Yeah, that is impossible. Yeah, probably cool, but impossible and sort of unpractical. We need to have tools that make the life easier. And this was the reason for the development of HML, which especially goes into models that are smaller, but can be extended also for models that are larger. In principle, it is agnostic of that, and contains all steps that you need to do your data analysis, also to store your data, to mix your data. And the tool you see here, the tool is, by the way, operated by us and can be accessed worldwide, and there are about 500 labs in also research labs from the industry which are using this tool. And you can integrate anything, of course, our own platforms, but also typical platforms that are used in many embedded systems, like embedded systems also integrated in Trumpf machines, of course, which are based on the two large architectures, Cortex and RISC-V, which are used there. But you can also, of course, integrate larger devices like as sources, like smartphone or smartwatches. But you can also use it for just using your CSVs, if you have it file-based, or using it via web API and integrate it fully in another application by using REST interfaces. And as I said, it goes through the whole chain, from the collection, labeling, training, validation, and then also the deployment. So at the end, you get the model. And you get this model, if you like, yeah, and use the standard parameters without writing any line of code. Yeah. By just selecting things, of course, you can interfere at any point, also via APIs, and add some code or change some code if you like. And as I said, it's running. You see app HML.org. You can use it just now with your smartphone, collect some data and train a model, and then detect something. Yeah, of course, you should a little bit know what you are doing. And here is the more complex thing. You have a lot of technical things that you can do if you want to do it, but you don't have to. And this is important that we have such tools, yeah, which everybody can use, yeah, without doing the deep dive into the technology. And that's also my last slide. Thanks a lot for the patience, and I'm happy to take some questions.